Hello, geometry students. Hopefully by now you have completed the Desmos activity for the congruent triangles test review. And here is a video with the explanations on how to do these problems from the Desmos activity. After this, if you feel comfortable, then you can go take the test, which is a Canvas test. It is very similar to this review here. There's questions about what makes the triangles congruent, and there's a couple of problems about proofs. The test will be open through next Wednesday, so if you are not ready for it yet, you still have the opportunity to ask questions. You can ask some questions in class next week at the beginning of class, or you could come to the office hours next Wednesday to ask questions. Okay, so we have several problems here. Determine if the triangles are congruent. If so, state how. So when we look at this first picture right here, then we see that we have a side and a side of this triangle, congruent to a side and a side of this one. And we look at the picture, we can tell that our vertical angles right here are congruent. So that's an angle. And so these triangles are congruent by side, angle, side. For our next picture, number 2, we have a side and an angle, congruent to a side and an angle. We once again have vertical angles right here at the center. So we have two angles and a side, and our question that we want to ask is this angle side angle, or is this angle angle side? And our difference lies in, is the side connecting those two angles that are marked congruent? Excuse me. And as you can see on this picture, with one angle here and the other angle here, this would be the included side. The side that is marked here is not the included side, and so this would be angle angle side, not angle side angle. For number 3, here we have an angle and a side and an angle, congruent to an angle and a side and an angle. This side is the included side, and so this would be angle side angle. For number 4, we have an angle and a side, and down here we have an angle and a side. Once again, we have vertical angles right here, and so we have another angle. And the question once again, is the side the included side between those two angles to make it angle side angle, or if it's a not included side, then it would be angle angle side. Here, looking at our two angles, this one would be the one that would be the included side. This one over here is not the included side, so this would be an angle angle side problem. Number 5. We have a side and a side, congruent to a side and a side. There's nothing else we could tell from the pictures. We don't have a shared side. We don't have any vertical angles here. So these are not congruent. Moving on to number 6. Here we have a side and a side, congruent to a side and a side. This time, though, these triangles are attached to each other. They do share a side. So this middle part right here, this is congruent to itself, and it's in both triangles. So these triangles would be congruent by side, side, side. Next, on number 7, we have a side and an angle, congruent to a side and an angle. These triangles are adjacent to each other. They are attached to each other. So this side right here that is in both triangles is equal to itself. And so now we have a side angle side congruence. Number 8, we have a side and we have an angle, and they do share another side. But when we look at this side right here, this is not a side angle side problem because the angle is not the included angle. This looks like an angle and two plain old sides, but we know that angle side side is not a congruence theorem. But before we say it's no, take a look at what types of triangles we have right here. We have a right triangle, and it turns out that this side over here is the hypotenuse, So instead of just calling a side, that's the hypotenuse. And this leg right here, sorry, I didn't mean to write a leg for that one. Thinking about my next step, this is the hypotenuse, and the shared side is a leg, so these are congruent by hypotenuse leg. For question 9, we have an angle and an angle, and over here we have another angle and angle. We do know that we have vertical angles, so these are congruent right here, but angle, angle, angle is not a test for triangle congruence. You do need to have at least one of the sides congruent, so these two triangles and this problem here are not congruent. Problem number 10, we have two triangles that have a shared side. We have an angle, angle here, and we have an angle, angle here. These do have a shared side right here, and this shared side is the included side between these congruent angles, and so what we have here is angle, side, angle congruence. Okay, now we get into a little bit different types. We have information that's given to us, and we need to take that information, figure out what does it mean, and mark it on our picture, and then make sure down here when we write our congruent statement that we put things in the correct order. So we have first that BA is perpendicular to AE. Perpendicular means makes a right angle. So find BA, that's the left side, AE is the bottom. If it's perpendicular, then we have a right angle. We also have DE is perpendicular to AE, so that's the right-hand side is perpendicular to the bottom, so that means we have a right angle over here. We're also told that C is the midpoint of AE. Midpoint means we're going to have congruent parts. AE, that's our bottom part. So if C is the midpoint, it's in the middle. That means the part on the left and the part on the right are the same size. They're equal halves. So AC is congruent to CE. We are also told that AB is congruent to ED. So the left-hand side, AB, is congruent to ED. And I want to make sure to mark those accordingly. The AC and CE are equal to each other, so 1 mark. The AB and the DE are equal to each other, so 2 marks on those. And now we do have triangle congruence. We have side, angle, side congruence. And the order we would put that in, for ABC, we have to list this one over here on the right in the corresponding order. So since A is listed first, that's our right angle, we need to start over here with E. And then since B is listed second, that's this one up here, the corresponding angle over here is D. And ending with C down here, the corresponding angle C. So this would be triangle EDC is congruent by side, angle, side. Number 12. We have BH bisects AG. That's an important word for us, bisects AG. And when I see the word bisect, I always like to circle what comes after it, because that's what's being split in half. So bisect means split in half. What's being split? AG. AG is this one right here, and it's being split in half, so that means that AC and CG are equal to each other. We're also told that angle A is congruent to angle G. So angle A down here, and angle G is up here. Now that by itself doesn't tell us we have congruent triangles, but when we look at the picture, we can see that we have vertical angles right here in the center. So this angle C and this angle C are congruent. So we have angle, side, angle congruence, because that side is the included side. So angle, side, angle. And when we write our congruent statement, we need to make sure to match up the parts appropriately. Starting with angle A over here, this is the one where I have marked it with 1 congruency mark. So I need to start with G up here. And then moving on to B, the one that corresponds to angle B is angle H. And finishing with angle C and its congruent angle over here at C. So triangle ABC congruent to triangle GHC by angle, side, angle. Number 13. We have that JC is congruent to BC, so let's mark that. JC and BC are congruent. And we know that CA bisects angle JCB. There's the word bisect again, means split in half. And what's being split in half is the thing that comes after the word bisect. angle JCB. Let's find angle JCB. JCB. So we're talking about the angle down here. If it's being cut into two equal parts, that means that these two angles down here are equal, BCA and JCA. Now, those are only two parts, but we can tell when we look at this picture that these triangles have a shared side. Side AC is in both of them, and it's congruent to itself. So now we have two sides with the included angle. So this is a side angle side congruence. And make sure we put them in the right order. A, B, C is congruent to A, J, C, matching up our parts. For number 14, we have BR is parallel to AC. So let's talk about that. BR is parallel. That means that the top and the bottom are parallel to each other. Now, parallel doesn't have to mean congruent. This other statement that comes right here says RB is congruent to AC. That actually tells us they're the same length. But parallel does not mean that the segments are congruent to each other. When we see parallel, we want to look for alternate interior angles. So if the top right here and the bottom are parallel to each other, then that means that this angle, RBC, and this angle, ACB. These are our alternate interior angles that are congruent to each other. Now we're also told that RB up here is congruent to AC down here. And we can tell when we look at this picture that we have a shared side in BC. So BC is equal to itself. Now we have two sides and the included angle congruent. So that is a side angle side. And we need to make sure to list them in the appropriate order. Triangle ABC corresponds to triangle RCB. I'll make sure to pay attention to that right there, because angle A and angle R correspond. Angle B does not actually match up with B though, because these two are not equal. Take a look at this right here. The last one that's listed, angle C, that's the one that we have our congruency mark on, which is congruent to B, so we need to make sure to list them in the correct order here. Our last two problems are proofs. Sorry, they're a little bit smaller, a little bit hard to see, but we are given that C is the midpoint of BD and C is the midpoint of AE. We're trying to prove the triangle's congruent. So first, we want to take our given information. We're given that C is the midpoint of BD, so we would write that. C is the midpoint of BD. And our reason there, how do we know that? It's given to us. We're also given that C is the midpoint of AE, so we state that, and we know that because it's given. Now moving on, we're looking at what does that mean. So what's stated is that BC is equal to CD. BC over here is equal to CD over here. And how do we know that? Because that's what midpoint means. That's the definition of midpoint. Definition of a midpoint. Well, we had two statements about midpoints. We were told that C is the midpoint of BD, which means BD is being split into equal parts, BC and CD. And also we're told that C is the midpoint of C is the midpoint of AE. And so AE is being split into equal parts. AC is congruent to CE. So that's what would be our fourth statement right here. We would have AC is equal to CE. Then after that, our next statement is that angle BCA is congruent to angle DCE. All right, BCA, that's over here, and DCE, that one's over here. And how do we know this? Because those are vertical angles. So vertical angles are congruent, or just vertical angles would be enough. And then once we have all of those pieces, how do we know that the triangles are congruent? Triangle ABC is congruent to triangle EDC because side, angle, side congruence. And there we go. And our last problem on here, again, it's a little bit small, but we can see it well enough. We're given that WY bisects angle XWZ and WI bisects angle XYZ. Prove the triangles are congruent. So our first statement, WY bisects angle XWZ. How do we know that? Because it's given. And then, notice that our next statement right here is not given. It jumps down. Let's see what this tells us. WY bisects angle XWZ. I'm going to switch colors for just a moment. Angle XWZ is the one up here at the top. So if we're splitting angle XWZ into equal parts, that's telling us that these two angles are congruent, ZWY and XWY. So our second statement would be that angle ZWY is equal to angle XWY. And how do we know that? Because that's what it means to be an angle bisector. It's the definition of an angle bisector. Our third, we know the reason is given, so we're just going to take the other part of our given, which is WY bisects angle XYZ. And what that means for us is that, I'm going to change colors again. Angle XYZ is the one down here at the bottom. So that means the bottom angles are being split into two equal parts. So these are congruent. And I just wrote over my letter there, so I'm going to erase that. So that means that angle XYE, that shouldn't say XYE, that should say XYW, is congruent to ZYW. And that reason is because that's the definition of an angle bisector. Definition of angle bisector or definition of bisect is fine. And for number 5 here, we have that XY is congruent to YX. That is our shared side. So we'll mark that. I'm going to erase this other part over here because I don't want any confusion thinking that I was stating that these are equal to each other. I was just highlighting my angles there. Okay. So now how do we know that these are equal to each other? Because that's our reflexive property. And then our last statement, that triangle WZY on the left, is congruent to triangle, that should say WXY, not WZY again. Sorry, that should say WXY. The reason there is because we have angle side angle congruence. And there we go. That's our review for the test. Now you can go over to Canvas. There is a link on the home page that is called Unit 4 Congruent Triangles Test. If you have questions, please feel free to contact me. I will see you guys next week. Bye-bye.